Alright, welcome back everyone. So here we have problem 4 of the 2018 MIT Integration B qualifying exam. We have problem 4, which is the integral of 1 over tangent x plus cotangent x dx. So let's go ahead and jump right in. Alright, so evaluating this problem, we kind of see that we have tangent, we have cotangent, both are in the denominator. And I feel like we have tangent and cotangent, so we can probably somehow combine them. So what I'm going to try and do to start off with is I'm going to zoom in a little bit. And we're just going to go, I'm going to say we have an integral of 1 over the tangent. And we're going to multiply tangent x by tangent x over tangent x. And that's multiplying by 1, so we're not changing anything. But what we get tangent x squared over tangent. Plus, we're going to also multiply, or actually, not multiply, we will move our dx to the top. I'm just kind of moving it over there. And we can add, or kind of unwrap, our cotangent, which is just 1 over tangent x. And because we have that, now we have, we can combine these two fractions because they have the same denominator. So we have 1 over tangent squared x plus 1 over tangent x dx, right? And we know that is actually the same as, move down a little bit, that is the same as writing tangent x over tangent squared x plus 1 dx. Alright, so now we're going to go ahead and we're going to pull in one of our memorized trigonometric identities. And the trig identity we're going to use today is tangent squared x plus 1 equals secant squared of x. And you can actually derive this from sine squared plus cosine squared equals 1 by doing something similar to what we did up here in this step up here, and multiplying by something over itself, but that's beside the point. And so we're actually going to kind of substitute this in for secant squared. Remember, secant squared, we actually can use that because we know that it's going to be, well, 1 over cosine squared. We know it's going to be in the denominator, but I'm getting ahead of myself. So let's go ahead and just rewrite the whole problem. If I can move my screen. There. Okay, so we're going to rewrite the problem up here. We have our integral. Move that there. We have the integral of tangent x, which I'm just going to write as sine x over cosine x. And that's multiplied by 1 over secant squared x dx. Another way of writing secant squared is 1 over cosine. So 1 over, because it's in the denominator, 1 over 1 over cosine moves this cosine squared to the top. So we have sine x cosine squared x, right? And that's just 1 over secant squared, all over cosine x dx. So this can be removed from the top, makes that power of 1. So we have the integral of sine x cosine x dx. And now we can just do a basic u substitution. We have u equals sine x du equals cosine x with respect to x. That makes our integral the integral of u du, right? So du is this right there, and u is the sine x. So I'm going to move my screen again and see if I can go over here. Nice. So the integral of u du is 1/2 u squared plus c which is the same thing as saying, using our sign we know from here, 1/2 sine of x squared plus c. That is our answer. Awesome. Good work.